Hi, my name is Megan Taylor and I'm the founder of Trellis Education. I taught 6th through 12th grade mathematics in the San Francisco Bay Area and I'm a nationally board certified teacher in secondary mathematics. I'm here today to talk about what happens to units and teaching in the era of Common Core and why great units and great teaching are inextricably linked. So let's dive in. I'm going to hide myself for the rest of this presentation so you can see my slides, and I think it's fitting to start with Grant Wiggins and Jay McTeague talking about the Common Core standards. We already do this as a frequent reaction to the new standards, but in fact they contain significant departures from existing curricula with the ultimate aim of preparing all students for college and career success. Merely trying to retrofit the standards to a typical teaching and testing practices will undermine the effort. So our essential questions today are: what changes to our typical teaching and testing practices are necessary to implement Common Core well? And what does a more effective unit look like? What does more effective teaching of a unit look like? And where does what we already do fit in, like our existing textbook, or the projects we've used for years, or the grading and scoring norms that our department or school value? Well, we know that there are 4 big things that make up a great unit: big ideas and clear goals, assessments that provide opportunities to show what is known about those goals, classroom activities that provide pathways to them, and then, of course, the teacher. And we know that big ideas and the goals should be predetermined and fixed, as well as the assessments. Those are things that shouldn't change. It's the classroom activities that should change in dimension and length to provide pathways there. They're ultimately malleable, and Confucius said, when it's obvious that the goals can't be reached, don't adjust the goals, adjust the action steps. And I'm going to make a strong case today that the teacher is the most important part of a great unit and the implementation of a great unit, as I'm sure people watching this video don't need to be convinced of. Harold Astorius took a stab at thinking about what research tells us about what a coherent unit is, and I'm just going to summarize this with some categories. It kind of boils down to making kids think, valued mathematics and mathematical thinking, core teaching practices, better assessment, and rich classroom discussion. And if we go back to the top of these 4 categories, if we're talking about big ideas and clear goals, on Harold's map, we're really talking about valued mathematics and mathematical thinking. I'll point out that on this map, there's a suggestion that a balance between skills, concepts, and problem solving is really important in a coherent unit. But what does a balance among skills, concepts, and problem solving look like? And I think the answer is what we're shooting for. We know that great learning goals build knowledge and understanding of big ideas and essential questions. And essential questions are really the things that cause genuine and relevant inquiry into the big ideas and core content. They're things like, why study this? What makes the study of it universal? What larger concept underlies this? Some examples in mathematics are, statistics always lie? Or, how accurately can mathematics model the real world? Great learning goals also specify what students learn and not how. A lot of times teachers will think about writing in a lesson plans what students will finish, or how students will work. But what we're really talking about when we talk about these things is what the students will do in service of a bigger goal, like what students will recognize or how the skills will develop. Great learning goals also are prioritized and clustered, from things that are crucial to content all the way down to things that could be skimmed or left out. Understanding by Design talks about these as enduring understandings, important to know and do, and worth being familiar with. And I think that the nice thing is that the Common Core has done a lot of this work for us. Additionally, great learning goals include different types and levels of understandings, knowledge, and skills. So when we think about knowledge versus understanding, knowledge includes facts and claims and right or wrong, and understandings are the meaning behind those facts, the degree or sophistication of them. Another way to think about types of knowledge from Lee and Shabelson is in 4 types: declarative, procedural, strategic, and conceptual. Declarative might be something like knowing what the Pythagorean theorem is. Procedural would be how to use it, that you can apply it to actually find the side of a right triangle. Strategic would be knowing that you can only use it for right triangles. And conceptual would be knowing why it works, or why it works in only certain cases. Finally, levels of knowledge are important as well. Jerome Bruner talks about this as intellectual activity anywhere is the same, whether at the frontier of knowledge or in a 3rd grade classroom. The difference is in degree, not kind. Students don't just get something or not. Understandings vary in complexity, And all students need access to higher order thinking skills, despite computational deficiencies that are often not their fault. If I told you to draw a male human face, and I collected 5 examples, and these were the 5 that I got, the way that we tend to grade right now is by drawing a line somewhere where we say, these fail and these pass with respect to this goal. But there's a great deal of variation here, from human faces that look like a stick figure all the way up to basically a photograph. Let me give you another example. If I asked you to solve a system of equations, your levels of understanding of this might vary a great deal, from very beginning understandings to advanced understandings. So what might students with a very beginning understanding of this content, of solving a system, be able to show or explain or do? And what's on the other end? For example, maybe that they would know that the solution to a system is a point both or all equations share, or they might be able to correctly estimate the point of intersection of the 2 lines using a graph. Maybe going all the way up to the right side, they can correctly solve a system using an elimination method or a 3-equation linear system. And then there's understandings in the middle. These are subjective, and they depend a lot on your context and your students. But doing this work is powerful, and it helps you think about how you're giving access to the goals to your kids. The next thing that makes a great unit is great assessments. And this falls in the category of better assessment and core teaching practices. And really, when we think about great assessment, we need to get away from quantity. Asking the same thing many, many times in different ways has a decreasing return. If a kid can't factor a polynomial the first time, he probably doesn't need 5 more ways to show you he can't. Also, assess what you care about, but don't feel like you have to capture everything. No assessment is perfect. Furthermore, assessment's about kids being able to show you what they do know, not limiting access to some. And if you care about types and levels of knowledge, ideally at developing levels, you have to make sure you're assessing those things. All questions on all assessments must be linked back to your goals directly, specifically at these levels, and students must be given qualitative feedback whenever possible. If you want more examples of how teachers in the Bay Area are doing this particular work, contact me, and I'm happy to give you some examples. Next, the part of a great unit that is the most fun for teachers usually is the classroom activities. And these are the things that we do every day. Making kids think and rich classroom discourse are 2 really important parts of this. And I think that's why the teacher ends up being such a critical piece of great unit planning. Because the teacher spans all categories of a great unit in terms of what research tells us. And if you think about the nexus between great planning and great teaching, teachers are at the middle. Some people are talking right now about ambitious teaching, and that's defined as the kind of teaching that helps students acquire and understand knowledge, and then use it to solve authentic problems. Expert teachers are ambitious. They make planning and teaching decisions before, during, and after interactions with students that facilitate their learning in powerful ways. And they make these decisions really easily. They don't have to think about them anymore. They also share certain core or high leverage practices that reflect cultural, linguistic, and contextual responsiveness to their students. So if we think again about that nexus, we're talking about core teaching practices as one of the critical pieces of what teachers do. Some people define core practices as high leverage practices, or an action or task that's central to teaching. Carried out skillfully, these practices increase the likelihood that teaching will be effective for students' learning. They kind of have the biggest bang for their buck. They cut across many different curricula or approaches to teaching. They're ultimately learnable and foundational for developing more sophisticated practice. And they're things that teachers should continue to develop expertise in over time. If we think about the 10,000 hours approach to developing expertise, which requires that you spend 10,000 hours doing something, you spend lots of time in deliberate practice, and you get targeted feedback from a skilled coach. And let me pause just to say that the difference between practice and deliberate practice is that deliberate practice includes activities that have been specifically designed to improve the current level of performance. An expert pianist didn't get to be expert at piano because they just played the same song they learned the first couple years of playing over and over again. They figured out what trills and what pieces and what chords and what combinations were difficult for them, and they practiced those in particular. If we apply this to teaching, if it takes about 10,000 hours to develop expertise in core teaching practices, And deliberate practice, well, maybe you're practicing about 900 hours in the school year. You may or may not be getting targeted feedback from a skilled coach. Well, that'll only take 11 years. My takeaway from this kind of silly calculation is that we better be practicing the right things when we're working on our teaching practice and working on implementing units better. And at Trellis Education, we put our bang for the buck is on 6 core teaching practices, with facilitating productive discourse at the forefront of that. Our bottom line is that your teaching should focus on core teaching practices, important content, and gathering lots of information about what students can know and can do. And you should focus your growth on getting better at core teaching practices over time. If we go back to the nexus, core teaching practices and task-based units are really what we're talking about when we're talking about transforming classrooms with for mathematics. Now, a familiar map to a unit of instruction might be something like some kind of an intro lecture and some practice, maybe another lecture on another topic and some practice, some kind of a quiz, maybe another lecture, maybe there's a fun project in there at some point, some review, and an end of the unit test. And I know that the formative assessment cycle that is promoted by David Foster and others talks about administering some kind of a task and looking at student work and using that student work to inform teacher knowledge before informing instruction. We know that this kind of process should be the bread and butter of classroom work across a unit. But what really happens, and I know I was guilty of this, is that we tend to administer tasks, look at the work, maybe assign some grades, look casually over who got what, who didn't get what, maybe do a little bit of review if there's time, and then go on and administer another task, skipping some key parts of a formative assessment cycle. Really, I think this means that between a quiz and a lecture, and sometimes at the end of a unit test, we do that grumbling, a little quick review, and then we move on. Formative assessments, though, the right way to do the formative assessment practice really helps to diagnose difficulties and inform and change teaching. It motivates learners by showing them what they value. And when people say to me, well, I don't have time to do a formative assessment cycle this way, this would take so much more time, I refer to John Wooden, who said, if you don't have time to do it right, when will you have time to do it over? And like I said before, the research on the formative assessment process, when done right, shows that there's significant gains in robust long-term learning for students. One map to a unit of instruction is a different one, a task-based unit, the focus of today's talk. And it really revolves around essential questions, big ideas, and valued learning goals. And I'll give you an example. If we're talking about a unit on writing, solving, and graphing linear equations with these goals, perhaps we'd start with a summative task that really either works in concert with an end-of-chapter test or replaces it. Summative tasks might take multiple days, and they provide students final opportunities to demonstrate understandings, knowledge, and skills. An example of a good one is the Big Race from CPM. Secondly, a formative task is a task that provides students opportunities to deepen conceptual understandings and may be used multiple times over the course of the unit. These provide feedback to the teacher on student progress and feedback back to the students. An example of a formative task is high school graduation from illustrative mathematics. An entry task is a task that's a hook, it's a launch. It gets kids excited about the task and actually at the beginning also has a diagnostic purpose. They're open-ended tasks that uncover what students understand, know, and can do related to the big ideas of the unit and should be highly accessible to all students. An example of an entry task is the 25 billion apps 3-act task from Dan Meyer. Finally, an expert task. Expert tasks some teachers don't use every unit. They're big, they're messy. They're investigations or projects that provide students opportunities to deepen their understandings of mathematical ideas and compare and contrast ideas with others. They're right for facilitating productive discussion among students. An example of an expert task is How Much Folate from illustrative mathematics. This type of a unit then can be filled in with lesson series that connect assessments and are the flesh of the unit. This can be directly from teachers' existing curricula or textbooks. Unit maps can have, let's say, 4 of these types of tasks across them and be filled in entirely the rest with existing curricular resources, making doing task-based unit planning feasible for teachers. If you'd like more information or examples on anything I've talked about today, please contact us at trelliseducation.com. trailsmc.org.